All right, everyone, we're going to start talking about Module 2, Topic 2 a little more, but we're not solving equations anymore. We are solving inequalities. Let me move me a little bit. Put me right in the center. So when we're talking about inequalities, that means we're talking about not equal. Unless there's this line here, that line under the inequality statement does give permission for being equal, or in this case, less than or equal. In fact, both of these signs are using that less than, and I think of the less than kind of like a sideways L. I guess we should use this, sideways L. Okay, so when I'm thinking about less than versus greater than, you need to know that being equal or not being equal depends on if you use an open dot or a closed dot. So if it's a closed dot, it's because you're giving permission for that number to be the same or to be equal. Versus if you were saying it can't be that number, it strictly has to be greater than or less than. So the first thing we need to understand is open versus closed. Closed is or equal. Open means it's open space under that inequality, or it's not allowed to be equal, basically. Now, the main concept here is that you're keeping up with a rule. And if you ever multiply or divide by a negative number across that barrier, across that inequality sign, it forces you to flip the sign. So for example, on the left, I would divide by -2 to solve for x. Now because I moved a negative across that inequality, that sign in the middle will change directions, and it's no longer less than, it is now greater than, meaning that all of my solutions are -3 or greater. Like -4, or sorry, not -2, -1, or 0. Okay? For example, if you plug in 0, -2 times 0 is 0, 0 is less than 6. However, if you plug in like -4, -2 times -4 is +8, that is not less than 6. Now you want to be careful about numbers like this one. See, I'm dividing by +2. Yes, -6 is on the right side, but I didn't divide by a negative. So in this case, I would not flip the sign. And so that would stay the same. And I'm talking about values strictly less than -3. So there's our little warm up before we start talking about solving. So we are solving some 1-2-step problems, trying to get the variable by itself. Then we want to graph the solution on the number line. So similar to the other video about solving, I'm trying to get n by itself. -6 plus 12 means I have 6 is greater than n. And I really like thinking of it with the variable on the left, so I like to flip them so that n is on the left. But if it was pointing it in there, I make it point it in here as well. So this would be any value less than 6. This one, I would just subtract 13 to the other side, and next would have to be greater than -13. Go find -13, values greater. So notice that I didn't flip the sign there because you're not multiplying or dividing by a negative. I know on this one I rewrote it and I kind of flipped the sign, but I wasn't using that rule that we spoke about at first. I didn't divide by a negative, where that would force the sign to change directions. So let's look at one like number 4, for example. Number 4, I'm trying to get x by itself. So I'm going to write it down here to make it a little simpler to talk about. To get x by itself, I would have to divide -4 away from x. But that's exactly what I'm talking about. This sign would have to change directions because you divided by a negative. -60 over -4 is +15. And again, I don't like thinking of it this way. It's harder for me personally to think about it when it's 15 greater than x. I like thinking about it as x is less than 15. So I need to use an open dot again, and all values less than 15 are in my solution space. Let's go to, let's see what other ones we want to talk about. Let's try number 5. Trying to get v by itself. V is currently dividing by 10. So let's do the opposite and multiply by 10. 10 times -11 is -110. But I don't want to flip the sign because 10 wasn't a negative number. Okay, multiplying or dividing by a negative number would flip the sign. But again, I don't really want to think of it this way. I want to think about it v on the left, negative 10 on the right. And if negative 10 was greater than all my answers, then v must be smaller than negative 10, negative 110. So let's go open at negative 10 and go left. Remember that open circle means you cannot be or equal, so I don't want to fill that little point in on the number line. Let's try, I'm going to try number 54 next. I want to walk through that with you. So this entire side is dividing by 3. So I want to start by multiplying 3 to the other side. So 5 plus v is less than or equal to 24. And then subtract 5 to the other side to see that that has to be less than or equal to 19. Remember, subtracting does not flip the sign, only multiplying or dividing by a negative would do that. So here is an or equal. So I want to say I can be 19. 19 is a part of my solution, or any value that is going less than 19. Let's try on the next page, number 55. Or maybe it's number 11. Some of our numbers may be different, but the numbers in the problem should be the same. So let's start with distribution. Negative times a negative, positive 90. Negative times a positive 1x. Negative 9 times 1 is negative 9, but I also have the x there. And then I need greater than or equal to 261. So now I want to try to put my like terms together. 90 is positive, adding in a way with negative 9x. So let's subtract 90 to the other side. Negative 9x is greater than or equal to whatever 261 minus 90 is. And that would be 171. And in the next step, I want to divide by negative 9. So while I have that open, let's divide by negative 9. And basically, it looks like my value of the variable is negative 19. But you divided by a negative value when you went across. So you better, hopefully you remember to flip the inequality direction. And that is a major skill when we're talking about solving for inequalities, remembering that that's something that you have to do. So let's go to negative 19. It's a solid dot, and it's going less than negative 19. It can also be or equal to negative 19. Let's go to numbers, let's see. On my paper, it could be either 16 or it could be 60. This is called a compound inequality. In fact, I'll do both of these. If you're talking about an or type of compound inequality, a lot of times you'll see the graph going in two separate directions. Not always, but a lot of times it's like the graph could go left or right. There are values less than some value that work. There's values greater than some value that work. But something like this right here, this is more where it's trapped in between two values, and we'll just kind of see how this one plays out. So let's start with the first one. Negative 3m is less than or equal to negative 12, or 10m is less than 0. So I want to solve both of these. The first thing I want to do is divide by negative 3. And hopefully if you're tracking with what I'm talking about with this sign thing, we need to change the direction of the inequality because we were dividing by a negative value across that inequality. So that ends up giving us 4. M has to be greater than or equal to 4. So or equal, fill it in, that little line under it, and any value greater than. Well, the second one, I want to divide by 10 to get m by itself. M is less than 0. 0 over 10 is 0. But this one would be an open dot because I don't have permission for it to be equal to 0, but it has to be less than 0. And so now you kind of see what I mean about the graph. It's kind of going left or right. Any value less than 0 or 4 or greater would be part of the solution to the problem. Now, something like number 60, what a lot of students want to do is I want to write it in a way that it starts, and I want to try to get v by itself, but I want to work out of the middle moving both directions. So for example, let's say you didn't have the 7 on the left. I would want to subtract 8, divide by negative 5. Well, that would be true if you didn't have this side. I would want to subtract 8 and divide by negative 5 to get v by itself. So maybe you're thinking, or maybe you're not, well, not sure, but our thought process is maybe we could do those at the same time. So we could subtract 8, but instead of doing it just to one side, we could kind of go in both directions at the same time. So negative 7 minus 8 is negative 15, greater than or equal to negative 5v, greater than or equal to negative 35. Now similarly, I have negative 5v, that's a multiplication idea. So let's divide negative 5 out of the middle and go into both directions. But dividing by negative, both of these signs are going to change directions. V will be left in the middle. Negative 15 divided by negative 5, that is positive 3. Negative 35 divided by negative 5, positive 7. And so any value between 3 and 7, even including 3, even including 7, any value between those would be a solution to the problem. For example, 4. 4 is in the middle of those values. 8 minus 5 times 4. 8 times 4 is 20. 8 minus 20 is negative 12. And is negative 12 in between negative 7 and negative 27? Yes, it sure is. So again, we're trying to find values that would plug in for the variable and turn out to make the equation or inequality true for the entire problem. Just checking my time there. So both of these are similar. 17 less than 1 minus 8r less than 25. Let's work out of the middle. Subtract 1 from both sides. 16 less than negative 8r less than 24. Now I want to get r by itself. Divide by negative 8. But which direction? You're really going in both directions. But since you divided by a negative, these inequalities have to swap directions. And so now r must be between negative 2 and negative 3. Now it can't be negative 2 or negative 3 because they're not or equal. So I want to make sure I show those points being open and then any value in between them. So I'll leave you with those. Let's try a word problem. In many states, you must be 16 years old to obtain a driver's license. Let's define the variable. X can represent your age. Okay? In order to have a driver's license. So I could say, well, you'd have to be at least 16. You could be or equal to 16 or greater. As long as you're 16 or greater, you could have a driver's license. Or it's not safe to use a light bulb of more than 60 watts. So X could represent the watts in a light bulb. And you want X, in this case, to be less than 60. And I'll read really closely. It says, not safe to use a light bulb of more than. So it looks like or equal is okay. 60 or less. In both of those cases, or equal would be okay. I'll do one more with you right here. I've got coming up on a little over 1 minute. Your brother has $2,000 saved for a vacation. Airplane ticket $637. Write and solve an inequality of how much money he could spend for everything else. Well, his airplane ticket was $237. So the amount of money you want to spend, you can spend can be X. So you have a total of $2,000, but the money that you spend plus that $637 plane ticket, that better come out to be less than or equal to the total amount of money that you have. And so if we were to subtract that 637 over, we'd be able to see exactly how much money we could spend on our vacation. Hopefully this was helpful for inequalities. Just remember that rule, dividing by a negative flips the sign. Do one more problem real quick. Anytime you have an inequality and you divide by a negative, make sure that that sign changes directions. See ya.